Okay, Algebra 2 from Ms. Bell. I'm starting with number 12. This is part 2. What is the solution of the equation? So for both sides, what I ended up doing is I multiplied by 5. So when I multiplied by 5, that gave me b plus 6. 10 times 5 is 50. Now I'm going to subtract 6 from both sides, and so I get b equals 44. That's my final answer. What is the solution of the equation? I did the distributive property. 3 times y is 3y. 3 times a negative 5 is negative 15. I have my plus 2 equals 5 that I have left over. I combine my like terms. Negative 15 plus 2 gives me negative 13. I bring everything else down. I added 13 to both sides to get rid of it on this side, and then I divided by 3, both sides, y equals 6. What is the solution of the equation? You could see I did the distributive property twice. I combine my like terms. I isolate the variable on one side, and I get 3 equals p. You can go through those steps and look at them, pause this as needed. What is the solution of each equation? Okay, when I did this one, I did the distributive property, then I combined my like terms, and when I got here, I noticed I had the same thing on this side of the equation as I had on that side. Remember, when you have the same thing, obviously it's going to equal, and it would equal no matter what you put into that h in this instance. And so that's infinite solutions. No matter what number I put in for h, take any number, minus 16, it's going to equal that same number minus 16, no matter what you do. This one, right off the bat, I have these numbers, a 2 and a 5, added to 3 times a number. So that's going to tell you that's no solution. There would be no solution here, because once I work that out, let me see here, maybe showing it would help. So say I subtract 3z from this side. Well, I'm going to subtract it from this side. That gives 2 equals 5, right? 2 never equals 5. No, that does not work, so it's no solution. It's the easiest way to show it. Okay, for this one, I did the distributive property, and this is an inequality. Combine my like terms. The thing is, I have negative p ends up being greater than negative 24. I don't want to know what negative p is, I want to know what p is. So I multiply both sides by a negative 1, or I change the sign this side, I have to change the side that side. When you change the sign, when you multiply or divide by a negative, you're going to flip the greater than to a less than, or if this was less than, I'd flip it to a greater than. You just flip the sign. So my final answer is p is less than 24. Do the same thing here. Distributive property, combine your like terms, get the variable on one side, and that ended up being w is greater than or equal to 42. This one, when you end up working this out, subtracting 3x from both sides would have done it. Subtracting 3x from both sides, you get negative 10 is greater than or equal to negative 2. That is not so. That is no solution. I'm not sure where I got that 0 is greater than negative 8. I would have just done this. When you subtract 3x from both sides, kind of like what I did up here. I subtracted 3z from both sides. If I subtract 3x from this side, that means I'm subtracting it from that side too. So I get negative 10. Negative 10 is not greater than negative 2. It is less than. Okay, we have some number lines that we're going to be drawing here too for this one, for a compound inequality. I'm going to add 4 to all 3 parts. There's 3 parts to this inequality. It's a compound inequality. So when I added 4 here, I got rid of it. That's why I did it. I added 4 here, I got 2. I added 4 here, I got 12. Then I'm dividing all 3 parts by 2. 2 divided by 2 is 1. 2 divided by 2 is 1, 1x. 12 divided by 2 is 6. Okay, so this is going to look like this. It's going to be between 1 and 6, right? And it could equal 1, but it can equal 6. So, you know, it's going to be solid on the 1 and open on the 6 and everything in between. Any number in between these two, 1 and 6, like if I chose 2. If I threw a 2 in there, that would work in this equation. A 3, a 4, a 5. It has to be less than 6. So I could put 5.999 in there and it'd work, but not 6. Number 21, you're doing this one or this one. Okay, you can see how I did that and isolated the variable. Ends up looking like this. It could be less than 5 or greater than 2. For 21, absolute value. Remember when you do absolute value, it could equal this or it could equal negative whatever it says it equals, okay? Because when you go in there and work it out, go ahead and work this one out. Notice when I put a negative 1 in there, if I put a negative 1 in there, this would be 2 times negative 1, which is a negative 2. Negative 2 minus 1 is a negative 3. Absolute value of negative 3, guess what it equals? 3. Yeah, so that works. And then this number works too. 2 times 2 is 4. 4 minus 1 is 3. Absolute value of 3 obviously is 3. Same thing here for these two. But it's an inequality absolute value. So remember, you flip the sign. When you plug this number back in, you'll see that it works. Same thing for this one. Plug in those numbers back in, you'll see that how it works. Could equal that. All right. So hopefully this helps. If you need more assistance in your review for the midterm, please contact me. Either email me or and we could do a Zoom, or if you're in school, if you happen to be popping into school, let me know and we'll get you out of study hall and work with you.